Zig is a general-purpose programming language and toolchain for systems programming. They emphasize 3 major points. 1, no hidden control flow. 2, no hidden memory allocations. And 3, no preprocessors and no macros.
I think the promise of these new wave of systems programming languages is that could we bring back resource-efficient computing? And I think that Zig is, in particular, a very interesting player in the space because it's basically C with a few bells and whistles. I could see that the programs it generates to being very fast, very efficient. At the same time, I think that it has a lot of nice features that we expect these days in terms of data structures and generics and different build system. So basically, it's a better C, right? Hey, this is Sri. I'm a YC alum and a research engineer focused on natural language processing for search.
Hi, and this is Will. I'm also a YC alum, and I'm an independent researcher who's worked across e-commerce, cryptocurrencies, and financial industries. Welcome to the Technium, where we talk about the edge of technology and what we can build with it. An optimistic look at the road ahead. How's it going, Sri?
Pretty good. It's a great day. I'm wearing this nice, fun summery shirt, so yeah.
It reminds me of a wicker chair that I had when I was a kid, actually. But don't let me ruin your day. What are you drinking today?
Yeah, I've emerged from the depths of hipsterdom into something a little bit more mainstream.
Well, your shirt would say otherwise. I don't know.
Okay, so in order to compensate for this shirt, I have brought a more mainstream product. Diet Snapple, Snapple tea. Peach tea.
Yeah. Is it a southern thing? Because I guess I associate peach with Georgia, because I think it's a state fruit, or is it?
Yeah, it is. But I don't know if this has any particular association with that. But it's been a long time since I've had Snapple, so it should be good.
Right. So I have something, I guess, a little bit different. I headed over to 85 Bakery for some limited time mango coconut, I guess, milk tea. It's got coconut boba.
Wow.
Yeah, 85 degree. I think it's only on the West Coast. I've never seen it in the Mid-East. Maybe they've expanded, but it's like a Taiwanese bakery where they also sell milk tea type stuff. So.
Oh, nice. Not a prepackaged thing for once.
Yeah, I had to
expanding our universe of things that we can drink on this show.
Not bad. But the coconut jelly is I don't know, the texture's a little weird, but it is good.
All right. Cool. Well, what are we talking about this week, Will?
This week, we're talking about Zig. Zig is a general-purpose programming language and toolchain for systems programming. It basically allows you to write and maintain robust, optimal, and reusable software. So, what does that mean? I think we'll get into that, but I think when it comes to their marketing landing page, they emphasize 3 major points. 1, no hidden control flow, because a lot of times programming languages do various things under the covers to change the flow of execution. 2, no hidden memory allocations, and same thing, a lot of modern languages allocate memory willy-nilly without you knowing it. And 3, no preprocessors and no macros. And I think this is more applicable to systems level languages where you had a lot of preprocessor and macros and stuff. And so Zig aims to be a low level systems programming language without a lot of these things that are considered footgums in C and C++. So basically the creator of Zig, Andrew Kelly, I think his name, he took C and tried to remove a lot of the warts. And this is what he came up with. Have you heard of Zig or used it before?
I've seen it mentioned in the usual places, Hacker News, Lobsters, things like that. But it's part of this cohort in my mind of new-fangled systems programming languages, which include things like Rust, D, Nim. I think these are a few of these peers that are all vaguely systems programming, which is I think a pretty ill-defined term to begin with. But
I guess mainly it's just not used by web developers. So
yeah, right. Basically, it's not JavaScript, right? That's what they mean. But yeah, so I think that I've heard of it, and there was a big splash, I think maybe a month ago-ish as of this recording, where somebody wrote up how Uber uses Zig, or at least one aspect of Zig, which we can sort of get into later. So that's sort of what put it on my radar.
Oh, I see. Yeah, it's one of those things where, like you, I've seen it floating around here and there, and basically it had one major feature that caught my eye, and which is the compile time aspects, and that I've only seen in one other language, but since doing research into Zig, I found out that it's an old idea, and there's a couple other languages that have had this feature in there. So I guess nothing's new under the sun, but we find ways to make it new and make it interesting. So let's take a stab at it, right?
For sure. So what is interesting about Zig in particular?
Well, so I think one of the things that jumps out to me about Zig is how they wanted to make everything explicit. So for those of you that are web developers, you know that the contrast between, say, Ruby and Python is that in Ruby, it optimizes for developer happiness, where I guess if developer happiness is you can do whatever you want. Reflections, monkey patches, you want to do it this way, that way. There's like 2 ways to define blocks and like multiple ways to do metaprogramming. And so that's great. And then on the other hand, in Python, the philosophy is there's only one way to do something. Like if you want to do this one thing, it's likely everybody's just doing it that way. And so it's for readability and maintainability. And similarly, the contrast between, I guess, what was Go's philosophy against? Were they a reaction to something? Maybe like in the very beginning, it was like meant positioned as a systems programming thing, but I think they've since moved away from that. But yeah, I mean, like Go famously doesn't have generics, I think, right? It doesn't have generics. It doesn't have objects. It has something that is object-like in its interface, like
structs that have functions attached to it. Yeah,
basically. Right. It's a long way of saying object-like, but it's really not an object. And so they tried to strip a lot of things out that didn't make sense for it. Who are the creators of Go? Rob Pike, and these guys were like from Unix and Plan 9
Bell
people,
Labs,
right? Yeah. So it's not nothing when they have had, what do you call it, take on programming languages. And so similarly, Zig is like, well, C has a lot of warts, and let's try to figure out what we would do with something that is C-like, but we get to redo it from scratch. And so one of the things is the hidden flow control, because for example, in exception handling, it's one of the cases that control flow can just kind of jump somewhere, and it's not something where you can look at a piece of code locally and be able to ascertain like exactly what it could be doing, right? And oftentimes, I guess if you've ever like written in Java, like oftentimes you just don't know you needed to catch an exception, and because like you look at it, you can't tell from the code. You almost always have to rely on documentation. But like when people are writing, they just go through the happy case, and then it just gets thrown at runtime. And then you're like, okay, I got this ticket now. I have to resolve this issue. So people just end up catching everything and returning null because I don't know what to do, right? And so that in practice doesn't seem to do too well. And so Zig wants to make it very explicit how to handle. And so I think Go has the same style as well. Like one of the common C styles is that you execute something and it immediately the return is used as an error code, and you react to the error code with an if statement right after it. And so you get like a call if then for error handling, a call if then handling. And so you get kind of that staggered alternating pattern.
The joke is that Go programmers basically have a keyboard shortcut that says that expands to if error does not equal nil, return error. That like this is every other line is that in Go.
Right. Actually, I have an ex-coworker that said she had a coworker at Google who had barcodes up on his cubicle with a scanner, and so when he would scan it, it would type in like common boilerplate for him, and so he would just I can't I would imagine he would be doing that. And so Zig has a story for that where it basically takes the idea of defer. For those of you that don't know, I guess it's like defer is a keyword that when something is finished executing, it's guaranteed to execute and clean up whatever it is. And then it also has an error defer, which only executes when there's an error. So you don't have this like cluster of boilerplate for it. So that's one thing with control flow. With me so far?
Yeah. And actually, I think that control flow, definitely error handling is a super important aspect of control flow, because that's like one way in which control flow can be completely upended in your system. But a few other subtle ones are things like operator overloading. So a lot of languages allow you to have like things that secretly like look like you're just like adding, like there's a plus, but in fact, call out to some complicated like math routine like that you can write in your custom code, right? So you can make matrix multiplication look like just, A star B or something, and it like does a million things. That's another sort of control flow thing.
Yeah, math is the only instance where I think that operator overloading is a good idea. Like every other place I've ever seen it, it seems to be a bad idea. Like especially in Haskell, where everything is a symbol. I'm like, I can't look anything up. They have to make a specific search engine just for Haskell programmers because like it's hard to look up like 3 or 4 symbols. I'm like, I don't know what this means. So anyways, go on.
Yeah, so I think operator overloading is another instance of control flow being disrupted in other languages. And then as well in languages like C++, you have things that run implicitly called destructors, which run when an object runs out of its memory lifetime and then gets cleaned up. And destructors can also be arbitrarily complex, and bad things also happen when you encounter an exception during a disruptor, like when it's running. I think it's ill-defined, and so like the behavior is ill-defined, and so the general philosophy is not to do any complicated stuff in constructors and destructors.
Yeah.
And so like control flow getting disrupted causes all kinds of crazy stuff in other languages.
Yeah. And so Zig wanted to avoid that, and so they made everything as explicit as possible. So if you're looking at a piece of code locally, that's exactly what it's doing. There's no like crazy other things that's happening under the hood. And then other things like hidden memory allocations, like in other languages, like the compiler attempts to hide memory allocations and freeze from the programmer. And this could be problematic in domains where speed is essential. And so like you can see like in non-garbage collected languages, like it's one of the major reasons why people choose them, because they have their domain has a sensitivity to latencies, such as like games or like real-time financial systems, or I don't know, other ballistics, I guess.
Like embedded systems and things.
Yeah, embedded systems, vending machines, missiles, stuff like that.
Those two are very similar.
Right. I mean, it's true. I mean, actually, I wouldn't be surprised if vending machines nowadays are implemented with a Raspberry Pi. People are like, I can't be like dealing with an embedded chip or anything, but I don't know.
Yeah.
So what's weird about Zig, at least to me, is that the core language itself doesn't know anything about heap allocation. It doesn't do, like, everything is statically allocated. And so if you want anything allocated on the heap, you have to ask an allocator to do it for you. And allocator is actually in the standard library. And so the language itself like doesn't allocate anything for you. You have to be explicit about this allocation. And it's through the allocator that you try to maintain some sense of memory safety. But like, and so that's what you're relying on for memory safety in this low-level systems language.
Yeah, and I think it also makes a lot of sense for certain domains like games. The number one reason why I've heard people making their own allocators is for certain domains where you have lots of objects that get allocated and deallocated. You want to pool them. You want to do some type of optimization, so you have your own allocator that you write. And I guess Zig says upfront that it is not going to, as a language, care about how you allocate memory, or at least heap allocate memory, and you have to kind of make that explicit.
Yeah. And then moving on to the last one, like no preprocessors. Like for those of you that grew up on C or C++, there's all these like preprocessors where it gets run before you actually compile. And I've usually seen it for like cross-platform compilation, but that isn't always the case. I've seen like linked lists implemented purely in macros for I guess speed reasons or something else or another. But like it's almost like having another language like dovetailed on top of the language that you're trying to read. It's like a, what's the word, palimpsest? Is that the right appropriate word? It's like layers of layers. But in fact there's only two, but like it can get pretty difficult. Like I'm not like a C or C++ macro expert by any means, and I don't think I've seen my share of really complicated ones, but like that tend to ratchet up the complexity of any program that I've seen if you use it in clever ways, right?
Yeah, right.
And
but Zig does have some type of compile time processor.
Oh yeah,
when you say preprocessor, you mean like not the C type, like with the hashtag or whatever, the pound sign.
Yeah. Hashtag, right.
Hashtag. I'm Gen Z, guys.
Yeah, right. Throw it into Instagram and see what he comes up with. Yeah. I wonder if there's a pound define in Instagram. But anyways, but you're right. So this part we saved for last because this was what I thought was the most distinguishing part of Zig when I looked into it, in that there is a comptime keyword, COMPTIME, like compile time keyword that you can intersperse inside your language, so that Zig, when it's compiling it actually executes code at compile time that is part of your program, so that it can reify expressions or values of variables at compile time, so that you don't actually have to do it at runtime. And so there's a variety of reasons why you want to do this, but I think this was only the second time that I've seen something like that, which I thought was pretty cool.
Yeah, it is pretty cool, and it gives Zig an advantage over Go because you can use this comp time feature to implement generics, which Go doesn't have and maybe never will have.
Yes, and so I guess, should we go into that a little bit? Yeah, I guess, why not? We're still here, right, at like the compile time thing. And so I guess when you think about generics, for those of you that don't know, I guess generics is a way to generically define the type of something. I guess that's like not a helpful definition. So for
circular,
example,
yeah.
if you have an array of things, like usually in a typed language, you need to define the type of this array up front. So it's an array of ints, array of floats, or something like that, right? But what if you have an array, but it could be multiple different types of things? Like they're still the same kind of thing. They might be like game objects, or they might be like, I don't know, financial instruments, or whatever is under like a type umbrella, but they all have more specific types under this abstract type. And so the abstract type effectively is a generic. It's a way of saying we have something of this generic type, but like we don't know at compile time what this specific type will be at runtime. And so the syntax for generics in various languages have always been pretty terrible in my opinion. It adds a lot of line noise with the use of angle brackets. I don't know what it is, but angle brackets make everything look dirty. So
Yeah.
And so what Zig allows you to do is you get to define at compile time that this is a type that they can fill in, so that like when you compile the code at compile time, it can figure out what the type would be at that time. And so it would slot in the specific type of the variable at compile time, and then so that at runtime it doesn't have to figure that out.
Yeah. Makes sense. So basically, the way that it works is that the preprocessor fills it in, like you said, fills in that type. So like, let's say that you have a linked list, everybody's favorite, and let's say that in your program you wanted a linked list of ints, or a linked list of, I don't know, some custom data structure. And so at compile time, the compiler would look at the calls to like linked list,
Yeah,
with the type filled in, and then it would generate that type
yeah,
for you already filled in at compile time. Unlike a language like, let's say, Java, which I think basically has the runtime aware of generics and generic data structures and does some stuff, some other kind of stuff.
Yeah. So I think that's better said. So to take a step back, Zig basically allows you to fiddle around with the compiler at compile time. So it basically allows you to execute your own code at compile time so that you can do some work up front rather than deferring everything to runtime. So that if you need to do some like checks or like a reification of some concrete types, like you're able to do that.
Mm-hmm. Yeah. Importantly, though, so Zig says that there are no macros, in which I think they mean specifically that there's nothing that the comp time feature can do that would modify the syntax of the language or provide, some type of syntactic sugar, things like that, things that look like function calls but get expanded into some other thing, which is something that you see in a lot of sort of, what do you call, languages that have macros and reflection and metaprogramming. So Zig does not allow you to change how the language looks. It only allows you to access some amount of computation at compile time.
Yeah. Good point. And so those are kind of the three major things, and the main thing that jumped out at me was this compile time thing, which we'll get to a little bit later. But that's not it, folks. we have one more thing. With Zig, it has a really nice build system, and for those of us coming from web programming, I think we take the bit like the package management and like build steps relatively for granted. Exception is
what are you talking about?
Well, with
the web used to be a mess before Webpack, and
yeah, but
it's still a mess with Webpack.
Yeah, like I really dislike Webpack, honestly. Like it's, but I guess I was thinking of it in a generic way where like it's technically like it's not a compile time language, right? Like the JavaScript and Ruby stuff, like it runs everything at it's a dynamic language, so there's no interpreted language, so there's no compile time step. But that said, in the larger picture, what you're talking about is true for any project. Like we have a build step that has to like gather all these assets together and like minimize it and whatever the heck it is. And I don't know about you, but I personally don't really like Webpack at all. So
yeah, I think nobody likes their build system. There's either build systems that nobody likes or build systems that nobody uses.
Right.
But maybe Zig is going to break that trend. You were saying that it has a nice one.
Yeah, it has a nice one. I mean, like what do you call it? Rust has a pretty nice build system. Like compared to other system languages that are like, namely I'm thinking like C++, you have like auto tools and CMake and a whole host of other ones that are pretty complicated to use, and they all get like thrown together in the same project oftentimes. And even just contributing to an open source project can be difficult because you have to figure out the build system. Like getting things to build was considered a major achievement in these like C++ projects. Whereas I think in Rust and also in Zig, just building things is a one-liner. You just tell it to build, Zig build and cargo build for Rust. So that's one good thing about these low-level system programming languages. The other thing about
Yeah.
Zig is that it cross-compiles across a lot of different platforms. I won't get into it that much, but it's pretty extensive. Never heard of any of the other platforms besides like the like major ones like the x86 like 64-bit. That's the AMD, and I don't know what else there is. WASM, but they
ARM
host
these
a whole
days.
ARM these days. Yeah, actually my computer's also ARM. Oh no, it's not. It's the M1 whatever. Is it ARM? Yeah, I think
Yep.
so. Right? Yeah, that's ARM. So that's pretty nice. But then I think the one of the interesting things about Zig is that it's also a C compiler. It has a really great story about interfacing with existing C code. I think one of the things that really threw a really nice language like Elm into the shitter was that they didn't really have a good integration story due to the limitations of and goals of the language. One of the things that people wanted to do was interop with C much more readily, but because it's trying to enforce like pure functional programming, it couldn't maintain its guarantees if people just call into random JavaScript code willy-nilly. And so I think that really hampered its adoption, whereas Zig says, we're also a C compiler, so you can call into C wherever you want, and their tagline is, we're a better C compiler than C compilers are. So, and the reason why they make that is just that sometimes the Zig compiler can generate code that is faster than code that is generated by C compilers, because they are able to turn on certain flags that aren't on by default in C compilers for good reason. So,
Interesting. So I think Zig has a C compiler as a consequence of the fact that Zig has a very seamless interop with C. You can basically include the header files from C code directly in Zig, and it should work without like any FFIs and things. So it's kind of weird though. It's like it almost seems like a very, not a minor feature, but just like one of the many selling points of Zig is that it has this type of C compiler, or it has this kind of C interop. But then by happenstance, due to it having that feature, it also has a very good C compiler. And so I think I mentioned at the top of the episode, Uber is using Zig, but they're not using Zig the language. They're using Zig the C compiler to compile some of their C code that they have, which I found kind of interesting. And yeah, we'll put the article in the show notes about this engineer telling the story of how he managed to sell that idea. It's kind of a risky move for a big company like that to use Zig, but it's kind of cool that they have.
I think the story about Zig being interoperable with C is a major one that I want to emphasize a little here for anybody that wants to make programming languages, because it's the way that you can sneak in your language into the existing ecosystem. By definition, in programming languages, you already have incumbents like giants in the field. Like, unlike startups where you can find like a new niche that comes up, like it's relatively hard to do so in programming languages. And so what you need is some way for people to dip their toes into your thing, and for you to kind of backdoor it into any living system, new or old. And it's the same strategy that Clojure used with the Java ecosystem. They're like, well, we'll just build on the Java EVM, and so you can just use a little bit of Clojure and just sneak your way into it. And I think React was the same way, where you can just use a little bit of React, just sprinkle it in, no problem, right? And people can kind of dip their toes in. And I think for the same reason, like, a lot of people will get to try Zig as a result, because I haven't worked for really large companies, but like even at relatively small companies, like most people are afraid to be accountable for a large tooling or stack decision, I think, because either they've been burned by their coworkers too many times, or people just kind of like to stick to what they know. And so usually it's more often than not what I see programmers use as a metric proxy for evaluating a technology is how many other people are using it, which I think is a terrible one, honestly. I think Zig allows you to just dip your toes in a little bit, and it allows you to bring along your more conservative coworker to get with the game if they can just dip their toes in for a little bit.
Yeah, it makes sense. And I think that the rest of the design of the language is also similarly conservative in the concepts that it introduces. It doesn't try to assert itself too strongly as an opinionated programming language. I think that they've added only a modicum of sort of modern features that make programming a little bit more convenient. But it's certainly, I think, like, if you were to make the case of using Rust at a company or something like that, it comes with a lot of things, with the borrow checker, a whole different tool chain, and I'm sure it behaves quite differently as well at runtime. So I think compared to that, like, Zig is very minimalist.
I guess that's why there's a meme. What is it called? Rewrite it in Rust.
Right.
And I guess there's meme should help with that sort of thing. So So I think that's kind of a moderately brief overview of Zig, and I think the reason why you're excited about it is specifically that it has this relatively new, well, new to us, I guess. We don't see it in a lot of programming languages that you have access to be modifying the behavior of Zig with your program at compile time.
Mm-hmm.
So, like, what did you think when you first like came upon that? Because I've only seen it in one other place.
Yeah, I mean, I think that it's not, the idea of metaprogramming is not completely new, right? But I think that the general theme of Zig is that it's not doing anything completely new. It's like doing just enough of the new thing that makes that idea useful, while at the same time not going so far as to introduce unnecessary complexity. And I think that I was impressed by, I think the flagship use case of the sort of preprocessor was being able to generate concrete types out of abstract data types, right?
Mm-hmm.
To solve this sort of generics problem. I
Yeah.
thought it was a very clean way to do that. It sort of circumvented all of the nonsense and all the debates that entail from, generic, should we add generics? Like, if you are familiar with Go, like, this is a endless, like, bike shedding topic. And Zig just dealt with that, like, nipped it in the bud. I think it's super great. The other...
to jump up on that as well, it's also interesting that the build system for Zig is Zig itself. And so instead of like learning another language as part of the build tool or build system, you just use Zig. And so Zig is very good at finding the few tools that it has to apply to a wide range of things. Zig's like, okay, we have a programming language. Let's use it for builds. Let's use it for metaprogramming. Let's use it for the programming itself. And so it's able to do that, I guess, because they had it in their mind, but probably the language has an affordance for it. It's probably because it's designed for it. So yeah.
Yeah, I think that makes sense. I think that the other cool thing the other cool use case that I heard for the comp time feature is that in a lot of these C-like languages, you can do string interpolation, right? So you have like a format string, and you want to you fill it with placeholders, and you want to fill in the placeholders with some value at runtime, right? And so a lot of the time, that is a special feature that is built into the compiler, right? To take that format string and then convert that into code that interpolates the values into a string and outputs that.
Right, because it implemented like without special I guess operators, it can be pretty slow. Like strings are one of the slowest things to operate on, and we use it so often, right? And so string interpolation, you would want that. It would make sense that it's built into the compiler itself. But here you're saying that Zig didn't have to, right? Because
so Zig used this comp time feature to basically implement that. And also, one of the reasons why you want to do this at compile time is that you want to give, a lot of compilers give nice error messages, like let's say that you have a format string that has 2 placeholder values, but then you only pass in 1 placeholder value. Or you have a format string that accepts a placeholder value that you claim as a string, but then you pass in like some other data type. A lot of the time, the compiler will complain up front about it so that you can avoid the behavior, unintended behavior at runtime. So Zig can also do this. Using the comp time, they can look at the format string and then look at how many placeholders there are and do all that checking for you. So it's cool. Basically, not to go too deep into format strings, it's not super interesting, but just the idea that like you can do a lot of these things as a part of a standard library rather than having them baked into the compiler, baked into the language, things like that.
Basically, like whatever work you can do up front at compile time, you should, and that relieves the runtime. Like it relieves you of having to do that work at runtime, and interpolated strings is one of them. And like we mentioned, generics, like figuring out the specific types that go into a function or an array or something like that. And I think you mentioned another one of compiling SQL queries with like query builders, and that I think is pretty interesting because in a lot of the web frameworks such as Rails, they built like an ORM which includes a query builder, and it has to do all that during runtime. And so it would be nice, I guess. It should speed up things if you can just pre-compile that stuff, so you have the flexibility of a query builder while you're programming, but then at runtime it's just baked into it because at compile time you already know what the query should be, right? And so that should speed things up a lot. I thought that was a good use of this compile time feature as well.
Yeah, and I think another one that came to mind when we were talking earlier was also basically the serialization of data. A lot of the time you have data types that you want to send over the wire, and the way that you do this is that in languages that don't sort of support it natively, you can use something like protocol buffers or thrift or these type of languages, data description languages, which then you compile. You have a separate compiler off to the side, which then generates code that says, okay, here's a structure, and here's how to convert it into bytes, and then also vice versa, convert the bytes into that structure in memory.
This is more typical of like typed languages that are compiled, because they need to know specifically, like based on the bytes that are coming in, like there's no boundaries on the bytes as they come in, and so like this is the thing that structures them and places boundaries. Like it's how to throw a stream of bytes into a known structure, right? And so that's usually all boilerplate like code that you don't like to write. And so in protobufs, like you use the library to generate this boilerplate code for you, and so that's what you're talking about, right?
Yeah, exactly. And so instead, I think you could conceivably use Zig and the comp time feature, where you can pass in the Zig structure, the Zig struct definition, and then be able to handle those. And you can do that at compile time without using some separate thing that generates Zig code and then you linking that in.
Yeah, and in dynamic and interpreted languages, I think what I usually did a lot of like metaprogramming to do this sort of stuff, so, because I guess it's not typed, so I didn't care, and so that. But I'm pretty sure that was way slower than things like protobuf and stuff like that. It just allowed me to get away with doing that. Yeah. So these are just kind of like the new sort of things that we thought about doing, and we thought that was pretty neat. So if you have some experience in Zig, let us know in the comments below and what you've used the compile time stuff for, and we'd love to hear it and learn more about it. But then, like moving on to like the other segment where we have the second and third order effects for this, like what do you suppose would happen if Zig had worldwide and global adoption, where it's like a common thing? Like what sort of things would come out of it?
So one thing that I'm excited about is I also have an M1 MacBook now. I bought one recently, and it's really fast. It's super powerful, right? But the sort of tragedy of all computing is that it's sort of this like hedonic treadmill type thing where the hardware gets faster, and then as soon as software developers find out that like, hey, hardware is fast now, then they make the software slower to compensate, right? They like start writing like more and more abstractions and making more heavyweight.
Well, I think the saying is what Andy gives, Bill taketh away. So Andy Grove and Bill Gates. So
that's getting a little dated.
Right. Like who is it now? I don't know. But on the other hand, like with that, I guess I'll get into that after you finish your point. But like you were saying that like, even though we have faster and faster hardware that can do more and more things, like our daily experience of software is just that it's slow as hell.
Super slow. Yeah, and I think that a big reason is that in order to write code that is closer to the metal, right, so to speak, you have to use languages that are not fun to use, right? You have to write in C. Like the fastest, short of assembly, or the second fastest method of writing efficient code is using C or C++, which is even more bloated. And so I think the promise of these new wave of systems programming languages is that could we bring back resource-efficient computing? And I think that Zig is, in particular, a very interesting player in the space because it's basically C with a few bells and whistles. That's it, right? And so I think that I could see that the programs it generates to being very fast, very efficient. At the same time, I think that it has a lot of nice features that we expect these days in terms of data structures and generics and different build system. Like, so basically it's a better C, right? So maybe people are not writing C these days because they have to deal with make, or I don't know what you have to do.
I don't know. I thought that maybe just like a lot of C programmers don't blog, and so you're just still writing mountains of C, but we don't know about it.
Yeah, and it's also kind of like, I mean, it feels silly to say, but like programming is pop culture, right? Like we mentioned this before, and C is like not cool, right? But Zig is kind of cool. I think like there's a certain sort of appeal to it, and so if we can get a new generation of programmers to be interested in this type of resource efficient computing, I think it could be super great, and we can keep our M1 MacBooks fast for longer.
So then I thought about this a little bit, and I want to know what you think about like these 2 points that I think are forces that counter resource efficient computing. One is the economics of writing software. One is that like everybody just wants to ship as fast as possible, because we know like the high order bit is that regardless of like how great your software is, if it doesn't fulfill some sort of like customer value, like if people don't want to use it, then it's all for naught. And so the only way that people have figured out how to fulfill this customer need or value is to iterate quickly. And so you just put something in front of them and see if they kind of like they want to use it, and then you try to like iterate on that. And so when everybody wants to build fast, they're going to like take lots and lots of shortcuts. And so unless like resource efficiency is the default easy path, then I don't know that people are going to do it, right?
Yeah, I think that it's a good point, and there's a limit to this, right? Like, I think that Zig is not the language that anybody's going to use for like line of business applications. Like
Unless their line of business is like command line sort of stuff. But
right.
well, it is possible nowadays with like a lot of the developer centric or developer focused companies. But yeah. Point noted.
Yeah, but I mean, I think that there's just so much friction to like. Let's say that you're writing like a native GUI, for example.
Yeah.
Like, it's just such a pain to write C code, right? To write like the code that you need in order to
get a GUI up and running.
Yeah, to get a GUI up and running, right? It's just like such a pain.
It's not even C though. Yeah, like it's not even C. Even like the web, which is like, you know, like generating GUIs is part of its like bread and butter. Like we have a project called Create React App because it's just so onerous to create a like boilerplate React app. And like I feel like it's gotten out of hand because like it's supposed to be like a template that you use to boot up a React app, but then people want to keep it there, and so people started writing plugins for Create React App so that they never have to exit it. And I'm like, this is so not where we should be.
Right.
I don't know. I'm just ranting, but like I'm just saying it's not any easier for web, even though it should be our bread and butter just to get something up and running, right? So
yeah, for sure. And you know, actually, like let's leave the GUI point alone. Like maybe GUI is just like inherently hard, and cross-platform is hard. But you know, there's so many sort of like daemon processes that run in the background, even for something like, you know, like let's say that you write like Dropbox, for example. Dropbox has a like daemon that runs in the background to like sync data across the network, and there are many like examples of businesses that have these type of like OS level like things that need to run in the background. Now, I don't know what they use, like maybe they are using resource efficient languages and things like that, but you know, I can imagine that it gets in the way of their business to use something too low level because they have to ship across multiple operating systems. You know, maybe they need to make sure that it like builds across versions of all those operating systems, and maintaining that whole tool chain is, you know, sounds like it would be painful. So maybe they might opt to use a less, a dynamic language or something like that. Instead, I think if they find themselves in that situation and they can use Zig, and Zig has a nice build system, while at the same time, you know, having a few of these nice affordances while still generating optimal code, then yeah, I think that there are lots of use cases like that where just the programs that we don't necessarily see every day but are running in our computer. You know, if you open up Task Manager or your Process Inspector, there's tons of programs running. If all of those were a little bit more efficient, perhaps by being written in Zig, your computer would be noticeably faster.
Yeah, but then I guess what I'm getting at is like, unless you change the like economic incentives of how companies build software, like unless that changes, or maybe like the languages make the default path like resource efficient, I just don't see people doing it.
Yeah, I mean, I think that the build system is an important part of this because a big reason why you don't want to write in a big company, or not just a big company, but even any company at all, one of the reasons why you don't want to drop down too low level is because maintaining that build system and generating executables for all the different operating systems and operating system versions and whatever, all the different endpoints, you need to maintain basically an in-house build system team, right? And so a lot of businesses will say, well, this is not worth it. Like, you know, forget writing in efficient languages or low-level languages. Let's just write it in Python, right? Like, we're going to write our background sync application daemon in Python. And so instead, if you can make the case that, hey, let's just use Zig, and we don't have to worry about all this like build system nonsense. It has a nice build system anyway, and we just use this language, and it's also a pretty nice language, right? It's not like a language where it's like, presumably it's not a language that slows down the developers and gets them caught in the weeds in the same way that C would. And so I think it's a little easier to make the business case. Of course, yeah, they're like, it's never in the interest of the business to do, you know, the right beautiful thing code wise, but you could certainly, as an engineer, make the case to your business that, hey, at least this isn't going to slow the business down significantly.
Yeah, and speed is one of those things where it's insidious. Like it feels a little bit slower, but you're like, it's like you either don't feel it or it's imperceptible, and it's spoiling the frog effectively.
Yeah.
Like I've used software that used to be fast, but it got slow. I don't know why.
Yeah. And actually, speed these days is becoming a selling point. So
Oh yeah,
if you think about like a prosumer and developer tools like a Superhuman, and there is increasingly this trend where people want their computers to feel fast. And so, yeah, there could be a good business case to using Zig or any other resource-efficient computing language as well.
Yeah. Maybe, well, if game programmers can get it done, I guess the rest of us should be able to. But then again, those guys work insane hours. Like if you think that people in tech work long hours, those guys work insane hours. Yeah, okay. So then I guess the second one, which since the first one took up a lot of time, we'll just touch upon. Like when computers get, or do you feel like computers get orders of magnitude faster now, or no? Not necessarily.
No. Yeah, I think the biggest jump was probably with like the M1 chips.
Yeah, because before, when like in the 90s and early 2000s, when computers would get orders of magnitude faster, like you just could write slow software and then just wait, and that'll just speed up your thing. And so I can see how in contexts like that, you would never try to optimize for computers as they are right now, because it would become imperceptible, right? Because like if your speed up is 1,000 times, like you wouldn't ever do the work to speed up things that are in the first two orders of magnitude, right? The difference between the first and second order of magnitude gets dwarfed if you go 3 orders of magnitude, right?
Right.
So like there's no reason to, like, unless that sort of stuff like builds up, but like I can see that also as a reason where people just don't want to, it just doesn't make sense to put in the work.
Yeah. I think these days, those wins are harder and harder to come by. So yeah, I think maybe that's a reason to use this.
Yeah. So then kind of popping off the stack back to like what the second, third order effects are if like everybody uses Zig.
Yeah.
What were some of the other things? I was thinking that maybe it would make systems programming more accessible to more programmers, because definitely like C and C++ is reputed to be to the metal and complicated, and Rust is supposed to help with that. But Rust, as it turns out, is pretty complicated in itself.
Yeah.
And so maybe Zig will turn to the dark side eventually itself, because things are hard to keep simple. But maybe that would be the case. What do you think?
Yeah, I think that one thing that Go did in making the Go toolchain really, really clean and easy to use, and also their language be like very constrained and easy to understand, is that it created this whole new wave of, I think their definition of systems is sort of more on the like network services type of system, but it created this new wave of those type of systems where, Docker was written in Go, and I think Kubernetes written in Go. All of those new DevOpsy tools are like written in Go, basically. And so we're in this sort of renaissance of like new systems programming, network systems programming. And I think that Zig could do something similar, like you're saying, making systems programming more accessible to more programmers. So, if Zig really takes off because, you don't have to muck around with make and, Clang and linking different libraries and this and that, then maybe more people will create small utilities or command line tools will be written in Zig, but also things like operating systems, for example, embedded systems. Maybe all of those things we'll see a renaissance in more people doing stuff.
Yeah, maybe things in robotics or things like that.
Yeah,
because like the other thing is that it cross-compiles across a lot of different platforms from desktop down through embedded systems. And I think that has the advantage of letting programmers cross-pollinate between different platforms. Because a lot of times as a web programmer, I'm pretty much only doing browser-side stuff or server-side stuff. Like I'm not doing any mobile or like embedded programming sort of stuff. So if I ever have any ideas that involve either one, I'm like, I guess I'll just table it because I got plenty of other things to work on. But it definitely like limits the reach that I have. And the other thing is like different ecosystems, different platforms, different languages have their own culture of what they consider normal and the things that they consider best practice. And so cross-pollination of these sort of ideas usually can help. Like I've seen different ecosystems that are more open and those that are more closed, and the ones that are more open like definitely take good ideas from other places and throw it in, and they're able to try things a lot faster. So that I think could be a really good benefit of Zig when it becomes a lot more popular. And I think you also mentioned like it reaches also into when people are in beginner stages, like as a teaching language.
Yeah, I remember writing a lot of C code in college for the systems programming class. Even my networking class was.
Oh yeah, I remember that.
Yeah, like I think I wrote a key value store, like a networked key value store in C or something. It was horrible.
Yeah, I had to write an FTP server.
Yeah, stuff like that, right? And it was miserable because I understand why you might want to write that in C. Like I think a real server like that would be written in C, and like Redis and things are written in C for good reason like that. But it's miserable for people who are learning this, right? Because it's so easy to make mistakes. It's not comparable with your intro to programming language like Java or Python or whatever. And so I think it scares people away. It makes it so that only certain very hardcore type of people get into this type of computing. And yeah, I think just generally having more people feel comfortable with writing low-level code, feeling comfortable with that they can use some of the more modern ideas in computing rather than having to go back to the 70s or 60s or whatever in order to write performant code. I think it's generally a good thing.
Mm-hmm. Yeah, I don't have anything to say against that. As unlike the other thing, I'm like, well, maybe, but this, I'm always all for people getting more people into a particular field, because I don't know, the more monkeys you throw at typewriters, the different type of thing, you're gonna get a lot of crap, but you'll get stuff that you wouldn't get otherwise, because as Ratatouille says, a good chef can come at it from anywhere, right? So
yeah.
So then what as we were pre-gaming, we mentioned our pre-game a lot, but as we were pre-gaming, what was the other thing that you were talking about as a possibility for Zig?
Yeah, I mean, I think that Zig can cross-compile to many platforms, like we said,
seemingly easily. Yeah,
seemingly easily, right?
Yeah.
And
so the reason why we said that was he gave a talk and he gave a demo where he was able to do that for a very a really niche operating system, and so it seems like it's a likely possibility. So yeah, go on.
Yeah. So cross-compiling basically is targeting a different instruction set than the computer that you're currently running the compiler on, and what else has a different kind of instruction set than the computer you're compiling on is blockchain. Virtual machines.
Right, your favorite topic, even though you don't work on it at all, but
yeah,
your
that's
favorite thing is put it on the blockchain. So
yeah, so could you use Zig to target the Ethereum virtual machine or something like that, and have a nice language to write your smart contract code in? Like maybe you can write smart contracts in Zig. I heard Solidity is terrible for some variety of reasons.
Solidity is terrible.
Yeah, so maybe you can write it in Zig, right? If you have an EVM compile target.
I think it's possible. I think the thing that's interesting about this idea is the notion of compile time, because I'm not super familiar with Zig's compile time, but it seems what's possible is that you can use the compile time features of Zig to restrain your programming domain, because you can put compile time in front of expressions as well. Mm-hmm. And so you would be able to evaluate that at compile time so that you can constrain your domain. So for example, there's been a lot of hacks on Solidity due to a variety of reasons, but one of which is that the EVM is just a completely different operating environment than you're used to. So for example, if you run some code, you almost expect the computer to do what it says, but underlying Ethereum is the miners, and the miners can pick the order of transactions that can happen. And so if you have something that relies on, say, a random number that's generated, the miners can actually front run your code or keep running your code until they get the random number that they want, because otherwise they just throw away the transaction. And so there's all these sort of hacks that can happen. And so Solidity developers figured out conventions to circumvent these sort of things, such as the checks effects interaction, which we won't get into, but the reentrancy attacks. And so we just have conventions for that. And so instead of that, it would be nice to have compile time checks for these sort of errors that you can do in Zig. So rather than inventing a completely new language that compiles into the EVM, then maybe you can use Zig for that. So that I think makes it a really interesting possibility.
Yeah, I think the details of the flaw vulnerability that you're describing, if it can be described through some type of static analysis a framework, so you can,
that's the limitation. Yeah, it does have to be statically analyzable. Yes.
Yeah, but I think there are many types of things that could be statically analyzed, and I think we were discussing to what extent Zig allows you to do static analysis at compile time. But let's say, for example, that you could have a compile time function that takes in another function and uses Zig's reflection API and can traverse the the abstract syntax tree and do some static analysis, then that's really powerful, because basically you can plug in your own verifiers that can enforce certain constraints, assert different conditions, and then maybe mitigate the situations in which you write those type of vulnerabilities that you described.
Yeah. So that makes it pretty exciting, and I wonder if it can be applied to a lot of other different domains in which you need that sort of constraint. Maybe it would help people work together in a large group as well, because a lot of times we use like code reviews to enforce convention in a code base, but maybe people can find like conventions that they can stick to and then write libraries and packages that have these compile time constraints that enforce some sort of like domain level convention, not just like coding and syntax convention, but like domain level convention inside the code itself. That might be something that would happen if like Zig was more readily adopted everywhere.
Yeah, for sure. And I think that, a lot of these can be done, you could do all of this that we're describing in Lisp, but again, the advantage of Zig is that it doesn't allow, again, when you're working in a group setting, you don't want to allow people to use this compile time feature and macros and things to generate, their own domain specific language that you then no longer can like reason about, right? And so
and
Zig
we know
kind
that
of restrains that.
Right, and we've all had the coworker, or maybe you suffered at your own hands where you tried to invent your own DSL and eventually you're just like, where's the escape hatch, because I just can't do what I need to inside of this, right? So
yeah, exactly.
So I think those are the things that we came up with. And so overall, I think that's as far as we can see. But like, do you see like where else like Zig could go, or maybe the philosophy for Zig or some aspect like further out than we are at the moment?
Yeah, I mean, I think that Zig is really cool because there are a lot of different applications. When you hone in on simplicity as a design principle, then it makes it so that you can use this tool in lots of different domains and lots of different places. And you see this with like Lua, for example. Lots and lots of programs have Lua scripting embedded in them.
In it, yeah.
Even
like Roblox, the game, like its programming language, I think it's Lua, right?
Yeah, I think so. There are definitely games where the end user scripting language is Lua, and it's because you can link the Lua runtime in as a library and pretty trivially into any program. Right. And so it pops up in all kinds of places and allows people to then more people to use that. And I think that Zig, again, similarly, I think could end up in lots of interesting places. So you could, for example, if you have a larger application, let's say that larger application is not written in Zig, but you could have the plugin ecosystem, support Zig as a first class like language, and you write like Zig plugins for, let's say you have an IDE, and people want to write some plugins to that IDE. You could maybe use Zig instead of some other language.
Why do that instead of say Lua or something like that?
Yeah, I don't know, maybe performance, right? Like let's say that you have like
it's not interpreted, and so you can keep up the speed for whatever reason, I guess.
Yeah, and like so those kind of situations, I think that basically wherever you didn't want to give people C, because C is scary and it's kind of a pain to maintain, instead you can drop in Zig and achieve the same effect. I think it could be a really interesting language that you see kind of crop up in sort of unexpected places. Yeah,
surprise. And so I guess at this point, like how are you feeling about Zig? Like are you optimistic, or are you just kind of like we'll see?
Yeah, I mean, I think it is it's competing in a very crowded space, and there's only so much sort of oxygen, so to speak, in the room, right? And I think that Rust is a really big player. It's the name that everybody knows when people are thinking about the new wave of systems programming, right? And so I'm curious to see how Zig goes up against Rust. But there are also other players in the space, right? Like Nim and D, and those have been around for a very long time as well. So yeah, I mean, I like the design of Zig, certainly. I like the way that they're going about it, and as a team, I think they're not very big, but they have done some very, very impressive things, like that C compiler. They have the C tool chain, right? And so yeah, a very impressive team. Will it be the winner? I don't know. Hard to say, but I would be happy if it is.
Yeah, I think the loophole for Zig is the complexity of Rust. I think people will get to a point where they find that Rust is too complicated or too too correct, for the lack of a better word. Like Zig, like Rust tries to protect you from a lot of different things. I think there's different kinds of like memory errors. Like there could be spatial memory errors and like temporal memory errors and like database errors. Like I think like Rust tries to protect you from all of these. And I think people are going to find like little niches and instances in which they don't need protection from those errors. And so when you don't, then maybe you can drop a lot of the complexity of Rust for Zig so that you have a language that's just a lot simpler to use to get whatever it is that you need done. And so we'll probably see that. That's my guess. And I think one of the biggest strengths is what I mentioned before. It's seamless interoperability with C. And so that will just make it a no-brainer for people that need or want to use specific libraries in specific domains, like such as like graphics. Like you're not going to like rewrite all that stuff or try to wait for Rust maybe. And so you're just like, I guess I know these C libraries that do these things. I'm just gonna leverage it. So I might as well just use Zig. So, and then it's off to the races. So I can definitely see that happening.
Yeah. And I think, just touching again on the usage at big companies, bringing in a language at a well-established company is always a hard endeavor. And the main pushback is just what is the conceptual complexity that it introduces into the code base, as well as the operational complexity of maintaining a whole build, separate build system or whatever. And so by being simple, I think it makes it possible for a team or even an individual engineer to make the case that, hey, let's just use this for maybe a constrained sub area of the code base and where they might otherwise use C. And I think it's a pretty nice sell to like the leadership.
Yeah, so I guess unlike our other episodes, there wasn't as much call out to previous episodes. I wonder why that is.
Yeah,
could be related in some way.
Yeah, I mean, I think this is the first time that we've touched upon a language that is actually like minimalist, right? We've talked about unison and we've talked about Smalltalk and all of these languages that have this really, really far-reaching view of like what the world should be. Yeah. And I think Zig is on the opposite end of the spectrum, where it's like this is the world as it is, and we're not going to like make waves. And so it doesn't lend itself to like super utopian ideas of the world. And I think that in itself makes it like really interesting.
Yeah, I mean, I think it's definitely opinionated in a lot of different ways, but not in the ways where it's in an ideology. It's opinionated on how it makes things practical, I think is the difference. Yeah. And so, like, for example, the build system, they're like, we're not going to accept some third-party crappy build system. We're going to use Zig, right? We're going to make it seamlessly interoperable with C. We're not, that sort of thing. So definitely, I would say it's opinionated in that way. So yeah, I mean, with that, I guess, like, my take on Zig is I'm baking on its interoperability to shoot it to the stars. What about you?
Yeah, I might, next time I rewrite some common Unix utilities and write a blog post to put on HN, I might use Zig instead of Rust.
Yeah, maybe. I'm chuckling because I'm like, I don't know how many times you've actually done that.
Never.
Yeah, almost never. I think, well, so like you do a lot of more ML stuff. Like, wouldn't Zig be useful in trying to write like fast either utilities or stuff, or like it's not really useful because like in ML a lot of it is based on Python, which is an interface to say TensorFlow or what's the other one, PyTorch, and those things are already like written in C, C++ and optimized, and maybe they leverage like the linear algebra pack that was originally written in Fortran and cross-compiled into C, C++ anyway, so like there's not really that opportunity to do that optimization.
Yeah, I think it's not at the right level of abstraction. It's but maybe like some a lot of the things in ML ultimately boil down to some FFI somewhere, right? Some C library that gets wrapped in those outer layers. Maybe Zig could be useful there. I'm not super sure.
Well, that's not what you're doing day to day. Mostly what you're doing day to day is what, data cleaning. That's what I hear about ML anyway.
That's yeah. Don't remind me.
Yes. Too funny that I'm choking. So, we should cut. Time out. And so, I guess with that, I'm pretty optimistic about Zig. How about you?
Yeah, I'm going to actually use it, not just in just to write HN posts, but I think I'll actually try to make something with it. And yeah, it's gotten me excited about systems programming, so it's cool.
Well, let me ask you, have you used TLA Plus yet?
No.
Well, we'll see. Until the day, we'll keep checking back. We'll keep checking back. All right. Cool. So yeah, So that's it from us. If you like what you hear, comment, subscribe, ring the bell, whatever it is. Hit the subscribe button below to hear more from us. We'll be here every week in season 3 until we fulfill our season, and then we'll take a short break and come back. But we're here to always talk about an optimistic take on technology and what we can do with it and where we can go. So with that, this is Will.
And this is Sri.
And thanks for listening, and we'll see you next week. Bye-bye.